First thing we're going to do is I'm going to draw some parallel lines. And we talked about yesterday, I thought we did it in the other class as well, but they told me we didn't. But I know we did it in here. Just looking at those lines right there, are they parallel to each other?
Yes.
Is that your final answer, as they say? Can't tell by looking. Why? Yeah, I mean, this could be like just like half a degree different, and you might not be able to tell just by looking at it, okay? What tells you that these are parallel lines? If you had they're little arrows, and we put them like somewhere in between like this, okay? Now, it's different than the arrows at the end of the lines. Would you agree? So that just means it's a line, those arrows on the end. But the red ones inside of here, that means that the lines are what? Parallel. Okay, so I can say those lines are parallel. They might tell you another way. They might have up in the instructions. They might tell you that, we'll call this line L and M. All right. They might have up in the instructions that line L is parallel to line M. Do you see that? All right, so they may not have the arrows. Sometimes they do, sometimes they don't. But they got to tell you one way or the other, either by the arrows or by this thing right here, that these lines are parallel. So what we're going to do today, it's really important to understand if your lines are parallel to begin with. All right? All these things that we're going to do today, let me put this, starts off with this. And I'm going to shorthand it a little bit, but it says, if the lines are parallel, and I use the symbol for parallel instead of writing it out. Makes it a little easier, doesn't it? Then, and then, blah, blah, blah. There'll be stuff after it, okay? We're going to have about 3 or 4 things, okay, after this. So it all starts off with if the lines are parallel. So if you take a look at this, are the lines parallel? Yes, they are. How do you know? Because of the arrows right there. Or because of this thing right here, right? Either one. I got 2 different ways to show that these lines are parallel. So all these statements that we're going to do today start off with this thing. If the lines are parallel, then blank, blank, blank. Okay, whatever. What I want to do is kind of what we did yesterday. Now yesterday, on the 2 line, what do we call this line right here? Transversal. Very good. Okay, this is the transversal. So yesterday we had 2 lines cut by a transversal. That's the phrase that we use. We say it's cut, all right, by a transversal. That means it intersects the 2 lines. Everybody listening?
Yes.
Okay. Yesterday we had 2 lines. I never said anything about them being parallel, did I? In fact, yesterday I made them pretty obvious that they weren't parallel. Brett, this is your new seat right here. Okay? If that doesn't work, then it's going to be up here. All right, so yesterday we had 2 lines. We didn't say that they were parallel. We just say there were any 2 lines. And then we talked about the relationship between the angles. All right? So I'm going to do the same thing, but this time things are a little bit different. This time we have parallel lines. So let's mark the angles. And that pretty much looks like what we did yesterday, doesn't it? Yeah. With how we've numbered these angles right here. Yeah. Now what did we say about angle 1 and 5 yesterday? They're corresponding angles. Very good. What about 4 and 5? Good. Alternate interior. Yep. What about 2 and 7? Alternate exterior. What about 3 and 5? Consecutive. It starts with a C, but it's consecutive, right? Consecutive interior angles. So now you know the names of them, okay? But that doesn't really help you solve for anything, does it? Just knowing the names. But we are going to use those names quite a bit, so we want to remember what they are. First thing I'm going to do is say this. If the lines are parallel, let's just go different color, just to be different. All right, if the lines are parallel, then this thing is called a postulate. Okay, it's just basically a fancy geometry name for like a rule. All right, R-U-L-E, a rule. Like this is, this rule says this rule says this, right? Red line's got some rules, right? Everybody's got some rules. So geometry has some rules as well. This is called a postulate. A postulate is something that you just accept as fact that you don't have to prove. They just tell you, all right? They just come out and tell you that, boom, this is true. And we say, okay, you said it, I'll believe it. You got it? So we have one postulate that we're going to do today, just one, but then we're going to have a couple other things where we have a name for that. Here's the first postulate. The first postulate says, if the lines are parallel, it all starts with this, okay? So I'm not going to rewrite if the lines are parallel then. So I wrote it once, you follow me? I'm just going to write the dot 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 afterwards. If the lines are parallel, I'll tell you what, just take a look at it. Let's just see if we can kind of maybe just guess. Now this is not the best way to do things, but look at angle 1 and look at angle 5. What do we call those? Corresponding. What do you think, just off the top of your head, what do you think might be true about angle 1 and angle 5? They're the same. They're equal to each other, and they absolutely are. Now, the only way that they're the same is if what? If the lines are parallel. The only way that this angle 1 and 5 are equal to each other is if these two lines are parallel. Yesterday, I made the lines not parallel. Remember that? Would angle 1 and 5 be equal to each other? No, they wouldn't. Okay, they look really different. All right, but if the lines are parallel, then 1 and 5 are exactly the same. Do you see it? Because if you think about it, look, this line slants a certain way to this line. If this line's parallel to it, it's going to slant the same exact way, isn't it? So that means this angle that's formed is going to be the same as this angle that's formed right here because they're in the same spot. They're corresponding. So let's write that down. And I can shorthand it. The corresponding angles are equal. Now in geometry, a lot of people like to say congruent. We could do that as well. It doesn't matter. There's some geometry teachers out there that really would have a fit if I said equal. I just don't really care, to tell you the truth. I don't care if you say congruent or equal. Okay, some geometry teachers harp on the fact that we say congruent. But in this particular case, it doesn't matter to me. You could say equal or congruent. All right, so you with me? The corresponding angles are equal or congruent. That's a postulate. That's in the book. It's in a box and everything. Or they got a postulate something or other right next to it. 3-1. Yeah, it's in a box and it's in nice color and all that kind of stuff. But that's what it says, that the corresponding angles are equal. Let's mark all the corresponding angles. Okay, so that means angle 1 must equal what? Angle 5. And give me a reason. Why does angle 1 equal angle 5? Because they are what? Corresponding angles. And what's true about corresponding angles with parallel lines? They are equal or congruent. Okay, we got it? All right. Let's see what else. Let's do some other stuff with this. What about 1 and 4? What do you think is true about 1 and 4? Now, they're not corresponding angles, are they? What are they? They're vertical angles. That's right. What do we say is true about vertical angles? They got to be equal to each other. That's not to say the same. I mean, that's true. I'm not saying you're wrong. But we say that they're equal or congruent. Okay, let's say it like that. So 1's equal to 4. Would you agree? All right. Now look, as far as corresponding angles, is there anything that's corresponding to 4? 8. So what did we just say about corresponding angles? They're the same. They're equal. They're equal. Okay. So 4 and 8 are equal. So guess what I can do? I can put an arc there at angle 8. You see it? So watch. What do we have? Just knowing that the corresponding angles are equal, what angles do we know are equal so far? 1 and 4 and 5 and 8. All 4 of those angles now are equal to each other. All right? That's only if. What's true about the lines? They're parallel. That's okay. We got to know the lines are parallel before we can say that. You got it? Let's list it. Let's list just the corresponding angles. Okay, so angle 1 would equal what? Angle 5. Now remember yesterday, we never said that they were equal to each other, did we? We just labeled them. We just said angle 1 and 5 are corresponding angles. That's all we said. All right, but now today, since we know this postulate, now we can say they're actually equal to each other. Yesterday we couldn't. Today we can. All right, and again, I'll say it again, only if the lines are parallel. Do you see that? That big if right there? All right, let's list the rest of them. Angle 2. What would angle 2 equal? Look at it closely. 6. Angle 2 and angle 6 would equal each other. What about angle 3? Angle 3 would equal angle 7 and angle 4? 8. Okay, because that's the bottom right side. This is the bottom right side. So 4 and 8 would equal each other. Everybody see that? Okay, so those are all your corresponding angles. And if the lines are parallel, all the corresponding angles are equal to each other. We got that? That's very important that you understand that. All right, let's do another one. Now watch. We're kind of hinting at the fact of the next thing right here. Watch. 1's equal to 4, right? Yeah. And 1's equal to 5. Do you see it? Yeah. So 1 equals 5 and 1 equals 4. So watch. 4 equals 1, 5 equals 1. What do you think is true about 4 and 5? They got to be equal to each other as well, don't they? You see that? It's not really because they told us. They had to tell us that corresponding angles were equal. There was no other way that we knew they were equal unless they told us. But look at this. We figured out on our own that 4 and 5 should equal each other. Well, what's the relationship between angle 4 and angle 5? What's the relationship? What's the name? The stuff that we did yesterday. They're alternate interior angles. So guess what must be true then? That's right. All alternate interior angles are going to be equal to each other. If what? If the lines are parallel, right? Okay. So now look what we can do. We already said that corresponding angles are congruent. Now we can say that alternate interior angles are congruent. Write that down. Alternate interior angles. Brett, you writing this down? Do I have to move you again? Alternate interior angles are what? Are equal or congruent, however you want to say that. Let's list the alternate interior angles. We already talked about one, so what would it be? Angle 4 and angle 5. So now we're not just saying that they're alternate interior angles, now we're actually saying that they're equal to each other. Right? So 4 and 5 are equal. Are there any other alternate interior angles? 3 and 6. Now watch. Now, I'm going to put 2 arcs for that. Why did I put 2 here and just 1 here? Because they're not equal, right? They don't equal each other, right? But 3 and 6. So all the ones with 2 arcs equal each other, and all the ones with 1 single arc equal each other. Make sense? All right, so now what can I write down? Angle 3 is equal to angle 6, all right? Let's talk about the 2 arcs. Watch. Angle 3 has 2 arcs. What else should have 2 arcs then?
2.
Angle 2. Give me a reason why. Because they are 2 and 3 are what? Vertical angles. They're vertical angles, okay? What else could have 2 arcs? 7. Why? A couple reasons. Well, it's vertical to 6, but it's also what to 3? 3. They're corresponding, right? And what did we just say about corresponding angles? They're equal. Do you see that? Okay. So watch this. So now, go ahead, David, you can say it now. Look at 1 and 8. What's the relationship between 1 and 8? They're alternate exterior angles, and guess what they are? They are equal to each other. So I can jot that down too, can't I? So watch. The alternate exterior angles, are equal. All right? And let's list the alternate exterior. We already said one pair. Angle 1 and angle 8, they're equal to each other. And what else? 2 and 7. So angle 2 equals angle 7. We good with that? All right. Now watch this. This is a little bit trickier. Let's see how I want to do this. Watch. Angle 4 equals angle 5. Would you agree? Give me a reason why. Because alternate interior angles. I got a typo? What did I put? Angle 2 equals angle 2? Well, doesn't it? Yeah, I think you're right. Thanks for that. Angle 7. Is that better? Okay. All right, let's go back to this. Angle 4 is equal to angle 5. Dave, what do you need? No, you just hang on for a sec. Angle 4, you can be in too much trouble today, so you can just sit still. Watch. Angle 4 is equal to angle 5. So they're alternate interior angles. Tell me something about 5 and 6. Tell me something about angle 5 and angle 6.
They're supplementary angles.
They're supplementary. Why are they supplementary? Because they form a... Okay, they form a straight line. Give me a...
180 degrees.
Yeah. They 180 degrees. I'm looking for something else. 2 words. LP. Thank you. Linear pair. Okay, so linear pair. So that means, David, you already said it, but they form 180 degrees, don't they? So look at that. Now, watch what I'm going to do here. If angle 5 plus angle 6 is 180 and 4 equals 5, would you agree with both of those statements?
Yeah.
Now watch. 4 and 5 are exactly the same. So watch what I could do. I could take angle 5 and make it what? Angle 4.
Cross-country
So
team,
what's
you are
true?
now dismissed to get changed. Make sure you have everything ready to get on the bus directly from the pep rally. Also, cheerleaders, you are now dismissed, and after the pep rally, you can remain in your uniform throughout the end of the day. Thank you.
Watch. What must be true about angle 4 and angle 6? They add up to 180. So what can we say? We can say that angle 4 is
Javier
what?
Martinez and Bailey Spence, please come to
Give
the
me
office.
not equal. Supplementary, right. Supplementary to what? Angle 6. What's the relationship? What's the word about angle 4 and angle 6? No, not corresponding. They're consecutive interior angles. So what must be true then about consecutive... Why did I put equals there? What's true about consecutive interior angles? Yeah, give me a better word. They're what? They are supplementary. So write that down. So they are supplementary. I'll just shorthand it right there. Do you see that? So we could say angle 4 is supplementary to 6. I'm running out of time, so you have to write it down. And we can also say what? 3 and 5 are also supplementary to each other. That means they add up to 180. Okay?